So we can see from this particular graph or this particular curve which is formed in the shape of the parabola is that as the curve is in the form of x square minus of 3x plus 4 means a variable in x, and this curve is actually intersecting the x-axis at 2 points. It means that this particular curve, or we can say this particular polynomial, that is x square minus 3x plus 4, has 2 zeros. So with the help of this geometrical interpretation, we can find out how many number of zeros does a polynomial have. So let us suppose we are talking about this particular polynomial. So x square minus 3x plus 4 do have 2 zeros. We can see it from this particular curve or the graph that the curve is intersecting the x-axis at 2 points, and these 2 points are nothing but called as the zeros, and the zeros actually represent the x coordinate of the point. So there are 2 points over here which is actually on the x-axis, and those 2 points are 4, 0 and minus 1, 0. So these are the 2 zeros of x square minus 3x plus of 4. So this is the geometrical interpretation of the zeros of this quadratic polynomial. So let's just move on further and let's just talk about some of the cases that are related with the quadratic polynomial. So what are those? So let us suppose we are talking about the zeros of the quadratic polynomial. We have 3 cases in it. So let us suppose we are considering our equation as y is equal to ax square minus of bx plus of c formation, or plus of bx plus of c formation. So case 1 says when the graph cuts the x-axis at 2 points. So as we know that whenever we will draw any quadratic polynomial, so the quadratic polynomial's graph or the curve is always in the form of the parabola, either in the upward direction, either in the downward direction. It all depends upon the value of a. Whenever a is greater than 0, then the parabola will be in the upward direction. Whenever a is less than 0, then the parabola will be in the downward direction. So on the basis of this parabola, we can say that there are many cases where the graph cuts the x-axis at either no point, either 1 point, or either at 2 points. So let us suppose we are talking about the case number 1. It says when the graph cuts the x-axis and 2 points, means it is intersecting the x-axis at the 2 points, not and, it is at the 2 points. So let us suppose we are talking about this graph and we are drawing the curve which is in this form. So we can see over here that the curve is actually intersecting the x-axis at 2 points, that is at a as well as at the a dash. So these are nothing, or the x coordinates of these points are nothing but called as the zeros of the polynomial. So it is intersecting at 2 points, it means it has 2 zeros. So let us suppose we are talking about another case and we have a curve which is of this form. So the first one is nothing but a downward direction parabola, and this is nothing but an upward parabola. So we can see over here again the curve is intersecting the x-axis at 2 points, hence it must have 2 zeros. So let's just move on further, talk about the case number 2. Case number 2 says when graph cuts the x-axis at only 1 point. So let us suppose we are having this particular curve or the graph of this particular curve. So as we can see that the quadratic polynomial is actually cutting the x-axis at only 1 point. It means that it has 2 zeros which are actually similar to each other. Means let us suppose we are talking about half as a zero of the quadratic polynomial. So we have half and half, both of the zeros should be same. So this is the scenario for this particular curve. As this curve is intersecting the x-axis at only 1 point, it means it has only 1 zero, or we can say it has 2 zeros which are similar to each other. So let us suppose we are taking another example, another graph which is in the upward parabola form. So it is again intersecting the x-axis at only 1 point, that is A. Let's just move on further, talk about the case number third. Case number third says when the graph does not cut the x-axis. When it doesn't cut the x-axis, then it must be of the form this or either of the form this. As we can see, it doesn't cut the x-axis at all. So this is the case number third that may exist in case of a quadratic polynomial. So in case of a quadratic polynomial, always remember there are three cases. Case number one, when the curve may cut the x-axis at 2 points, when it may cut the x-axis at 1 point, and it may cut the x-axis at no point, or we can say it doesn't cut the x-axis. So from all of these, what we can conclude, the result we can conclude is a quadratic polynomial can have either two distinct zero or two equal, that is 1 0 or no zero at all. So from these three cases, we can conclude that a quadratic polynomial can have either two distinct zero, can have either 1 0, or we can say two zeros, but both of them are equal to each other, or we can say that there are no zeros. We can see from this particular graph that there are no zeros because the graph is not intersecting the x-axis at any particular point. So at the end, what we can say about the zeros of the quadratic polynomial, that a quadratic polynomial can have either two distinct zero or two equal, that is 1 0 or no zero at all. So this is all about the zeros of a quadratic polynomial, or we can say the geometrical meaning of the zeros of the quadratic polynomial. Let's just move on further. Now let's just talk about the zeros of a cubic polynomial. So in the same way, like we have talked about the linear polynomial, the quadratic polynomial, now we have to talk about the zeros of a cubic polynomial. So what is the meaning of that? So let us suppose we are considering a cubic polynomial y is equal to x cube minus of 4 of x. So in the same way, we will draw the graph, or we will plot the points or the graph of this particular curve. So let us suppose we are taking the values for the x and we will get the values of the y. So let us suppose we are taking the points. Let us suppose these are nothing but those points. So I have taken 4 coordinates over here: 2, 0, 1, minus of 3, minus 1, 3, and minus 2, 0. I have substituted all these x values in this particular curve, and after substitution I got the value of y, and I have plotted all those x, y coordinates on this particular graph. So after plotting these particular coordinates, let us suppose I am joining all these coordinates, and thus the graph that is formed, that is of the form y is equal to x cube minus 4x, is in this form. So from this graph, what we can say over here, from this particular graph, we can say that the curve is actually intersecting the x-axis at the 3 points. What are those 3 points? The 3 points are minus 2, 0, 0, 0, and 2, 0. The graph is intersecting the x-axis at 3 points. What are those 3 points? Minus 2, 0, 0, 0, and 2, 0. So the x-coordinate of all these points are actually nothing but the zeros of this particular cubic polynomial, that is y is equal to x cube minus of 4x. We are talking about this result because we already have learned about the zeros of the linear polynomial and the quadratic polynomial. So in the same sense, we are talking about the zeros of a cubic polynomial after seeing the graph of y is equal to x cube minus of 4 of x. So from this particular graph, what we can conclude that as the graph is intersecting the x-axis at 3 points, so the x-coordinates of all these points are nothing but called as a cubic polynomial. So always remember, a cubic polynomial's graph always intersect the x-axis. If it is in the variable x, so it intersects the x-axis at always 3 points, or at most we can say 3 points. So the x-coordinates of these 3 points are nothing but called as the zeros of the given cubic polynomial. So let's just see the graph of other cubic polynomials as well. So let us suppose I'm taking the example of two cubic polynomials. Let us suppose we have y is equal to x cube and y is equal to x cube minus of x square, and let us suppose I am plotting the graph of both of these cubic polynomial, and the graph for the very first one is nothing but of this form and the graph of the second one is nothing but of this form. So I have taken the coordinates of the very first graph in the form of 2, 8, 1, 1 and minus 2, 8, and taking those points I have drawn the curve in this particular formation, and in the same way I have plotted the graph of the second polynomial, that is y is equal to x cube minus of x square. Now what we can say after looking at the graph of these particular cubic polynomial, if we'll compare this graph with the previous one or with the previous cubic polynomial, what we can say at the end, we can say that a cubic polynomial can have at most 3 zeros, because we can see from the very first graph that it is intersecting the x-axis at only one point, and from the second graph what we can say that it is intersecting the x-axis at 2 points, but the previous graph says that the curve was actually intersecting the x-axis at 3 points. So it means that we can say that a cubic polynomial can have at most 3 zeros. At most 3 zeros. It can have 3, it can have 2, it can have 1. So at the end, the conclusion for the zeros of the cubic polynomial through the geometrical meaning is that a cubic polynomial can have at most 3 zeros.